Sure. Shavik, are you ready? Shavik, you are on mute.
Yeah, ready to start whenever we're
Okay,
good to go.
okay, let's start. Good evening, everyone. Welcome to the another PDP session by MathWorks. In the series of 3 sessions, we talked about how can you simulate the drones with using MATLAB and Simulink. How do you develop and generate code and deploy on your flight vehicles using your flight computer and flight controller. And finally, we are at the third session where we are going to talk about how do you develop the perception-driven smart drones. So here in this webinar, we are going to talk more about the algorithms and the methods which can make your drone smarter and helps you to complete your autonomous missions. So here we have Dr. Shavik Chatterjee with us, who is the manager of customer success engineering and would be presenting the various methods and algorithms and how can you develop them using the MATLAB and Simulink. He is going to talk about that. But before we start the session and jump about what all we are going to learn in this session, let me introduce Dr. Shavik. So Dr. Shavik is my bad. Am I audible?
Yeah, yeah.
Okay. So Dr. Shavik leads the education team in MathWorks in the southern part of India, and he's based out of the Bangalore office. He is advocating computational thinking and model-based product-oriented interdisciplinary approach in research and education, partnering with universities, institutions across the country. He is also the recipient of the Best PhD Thesis Award and Young Scientist Award from the International Society for Energy, Environment, and Sustainability. He worked in the University of Illinois at Chicago as postdoctoral associate and at Enterprise Works Chicago as strategy consultant for commercialization of academic innovations. He has co-authored multiple journal articles, book chapters, and is co-inventor of 2 US patents. Wow. He completed BE from Jadavpur University and a dual MS PhD degree from Jadavpur University and Virginia Tech. Uh, so we got a brilliant speaker among us today. Over to you, Dr. Shavik. We are excited to learn from you in this session.
Sure. Thank you, Kushin, and thanks to SA India for organizing this. Am I audible and the screen visible?
Yes, Shavik. It's visible.
And do everybody has access to chat? If you have access to chat, then feel free to use it whenever you have any questions, or if I ask questions and if anybody has some answers, please feel free to use the chat line so that we can make it a little interactive while we go through it. Okay. Um, Right. So today we are focusing on the perception part of drones. So uh, anybody can mention what does perception mean? If you have any thoughts, you can put in the chat. What does this word mean when we say perception? In general, when we are using in the technical field, we use many words. Some of these terminologies are for everybody to be in the same page, on the same page. To view. Thanks, Chiranjeevi. Yeah. So view is one part of perception. There are some other aspects. It's sort of, we call it view plus something, you can say. So once we view, and then what do we understand of the view, right? Um, so that, and if you see whatever in the bottom, these pictures are, so there is view, and then there are a bunch of these things, what we do in terms of, yeah, what Kushin mentioned, understanding from the view. So it's not only the view part, it's also what do we understand from the view, right? Which is like, if you think about humans, so our eyes is doing the viewing part, but our brain is doing the understanding part. And when we are saying perception, it's both together. So we are seeing the eyes, which is and for our eyes, what do you think will be the sensor? What will be the eyes of drones? You can again put in the chat. What are the eyes of drones? What sensor are we talking about? Camera. It's a straightforward question. No trick in this. Yes. Um, And so that's what we will talk about. So views and what do we do with it. And as you can see, things like once this is part of a bigger thing called the robotic systems, UAVs, as you have heard from Kushin and others as well. UAVs is something like a robotic system on air. And you can see, there's drones has landed, and the ground robots are happy when ground robots are also on the ground. So these are all part of these robotic systems. And yeah, no guess in understanding that this is a generated image and nothing else. Okay. So when we say drones, right, you have heard a lot of drones in terms of things that happens in terms of the structures around and the flight dynamics, aerodynamics of drones. But as we mentioned, just to give you a broader picture, drones are part of robotic system, and there can be multiple other types of robots. Like if I do something like a hand pick and place robots which walk, which sort of be on the ground. This is an actual experience we had in our autonomous drive vehicle. It's a company called Waymo, where we see that the car is moving on its own, right? Nobody's driving. It's also actually a robotic system. It's just on the ground. And seeing those things, a robot also gets surprised. Anybody knows which robot is this by any chance? If you know, you can put in the chat. This is an actual robot. It's not a generated image, by the way. The name of this robot is called Amica. It's some no, not Sophia. Yeah, that was a trick question. Sophia is a well popular one. This robot's name is Amica. It's created by it's a company called Engineered Art, and it was exhibited in 2022. So yeah. Right. So coming back to, I think what we are seeing in the drones aspect, it can be used in multiple cases. If you are part of the mini drone competition of MathWorks, there we have this line following robot. If you have gone for any weddings, you can see these drone cameras. But then there are other things like surveying, measurements, inspection, monitoring, package delivery, transport. There are all these things which can be done by a drone. And if you see in many of these things, there is an onboard camera that exists, right? This onboard camera here for surveying, there is a lot of experience, and we'll do some examples today. Inspection in terms of defect detection. So whenever we have a camera on board on the UAV, it does take some images. And what do we do on those images is something that is very important. Even if we have to do a package delivery, if we have to find out very specific location where we have to drop the package, there also we need to figure out what we need to do. So all these cases we sort of have to rely on the perception bit, which is vision plus understanding. Um, right now, I think just to give you a sort of perspective of where all this thing fits in, maybe we'll go step by step. So, I mean, first part is a platform. I think some of those parts you have already heard from other talks in terms of the quadcopter dynamics, 6 degree of freedom model, those type of things. And where perception comes into the picture is in the sensing part. You already mentioned about sensors as a camera as a sensor. Along with camera, we can have other sensors like, LiDAR and other things. And we have to do things like sensor calibration. So the whole bottom line is we understand or we take data from things on board or on the UAV itself. And after we understand, we have to do something called perceive. And that's sort of, you can see the word comes from the perception bit. But here, what we are also doing is we are doing a bunch of other things, right? Environment mapping. If we are taking a whole image of a agricultural field, we are understanding where we are, which is called localization. And these other things here, classification, segmentation, this sort of falls into the area of AI or artificial intelligence, deep learning. And that's where we will go into today as well. Because when we are doing things like that, we are using the data, but with the data, we are doing on top of them some algorithms, and that's typically the deep learning algorithms. Uh, so object detection, classification, segmentation, all these things are part of AI or deep learning. And the other thing we need to do is sensor fusion, where if you have different type of information, one from camera, one maybe from radar, LiDAR, and you have to fuse them. And there are different techniques to do those aspects as well. So once we are done with that, then we have to plan. Like after we know where to go, then we have to plan the path obstacle. You have to, if there are obstacles, then you have to avoid the obstacle. If there are some trees and stuff, we have to avoid them. What will be the shortest route to take? That's where we use many of the path planning algorithm. So that's where we plan things. After we are done, we have to control, like if say, for example, which motor of the UAV needs to be rotated at how much speed, which way to do the controlling so that we can maintain the altitude. And these are some of the things which we have also learned, right? So this is another aspect. And finally, after we are done with everything, we need to integrate with the hardware. And that's also something that we've seen about code generation, like how do we generate the code for the hardware and deploy it on the hardware. Along with the hardware, there are other things like you can integrate with PX4. There are things like if you're using ROS, then how do you integrate with ROS there? Anybody knows what is the full form of ROS? I've deliberately not added the full form in this slide of ROS. Anybody knows what is ROS? You can put in the chat if you know. Robot operating system, as many of you are saying. Correct. That is the robot operating system, and that's how we can integrate. How does that work? If you have, some camera connected to, say, a Raspberry Pi, if you have some sensor connected to some other controller, and if you have something else connected, so all these things, the common communication platform can become ROS. And that's how we can also do. You can have a MATLAB node as a ROS. You can have the hardware as a ROS node. And once we integrate all these things together, then ROS becomes the common communication platform. Like today we are talking in English, ROS can be that integrator, like that middleware or the communication platform through which all these different sensors and algorithms can talk to each other, right? So this is like the full, end-to-end sort of development of a UAV, or so to say, or if any robotic system, basically, this is how it works. But UAV also follows the same operation procedure. Is the platform changes, this part changes. If you have a, other type of robots of a manipulator or a car, this will change. But in general, for aerodynamics or UAVs, we'll use the drag coefficients, the lift, and the 6DOF models here. Then this part will remain the same. Then we have to add the controller. The controller designing will be a little different, but then the rest of the things will sort of remain the same in this context. Okay. Right. So once we know about all these things, let's go into a little deeper. So on the perception bit of things, which is about using this bit of image data, so camera on board data, and what do we do with it? Um, uh, I think there are a bunch of toolbars. I'll skip this thing. So again, for the full scale UAV development workflow, so we get, something from the ground station, the controller. So the plant is our UAV. We can do many of the scenario simulation and then onboard autonomy of the path planning aspects. And once we are done, we can deploy on different hardware, like the onboard autonomy. We can, if we have the deep learning with image processing algorithm, we can deploy it on the hardware, which is our say something like a Raspberry Pi or NVIDIA Jetson. Then the plant model, we can use things like speed code, other hardware. And then we can also have controllers for different parts of the system. Okay. Okay, let's see one example and then I'll run this. I think instead of doing this, I'll go over to MATLAB and we'll do there. So I think by this time you have seen pretty much MATLAB interface, right? So let me open up an example. This example is on package delivery. So what I'll do is I'll open up MATLAB. Let's bring up MATLAB. I'm just opening this example. So let's see a full thing and then we'll come gradually into the fundamentals of it. So the example that I'm opening up, you can also do that once you are in front of MATLAB. This is what it's called. It's called package delivery quadcopter. Okay. It's a model on a delivery of a package. No surprises in that. And this is doing a bunch of different things. Once the model opens up, we'll run it and see. Anybody knows which platform we are using in this thing where we are doing all these block diagrams and stuff? You can put in the chat window if you are aware of it. Simulink, yeah. And within Simulink also there is a sort of an extension on top of Simulink where we do many of this component level design, and that's what we are using here. So this is the model. So I'm just opening up in Simulink. So this is how it looks like. So this is Simulink, and then what platform are we using? Like where we have the 6DOF models. Anybody knows? Or these type of different joints and things, which contains multiple of these joints. and things like that. Maybe I'll run this and you will understand. So I'm running this. Let's see what comes up. So as you mentioned, it's a Simulink platform. Um, and where we have these blocks, right? This 6DOA for different joints. It's called SimScape Multibody, and that's what we are using at the back end here, SimScape Multibody. So this thing, once it runs, we'll see what happens. Yeah. So the good thing is it shows also, your visualizations like this. Um, yeah, so it's still running, and then this visualization comes up through which we can kind of see things as well. Um, okay. Yep. So now you can see there is this drone which is moving out. It's taken off. There is a package, this plus like a plus looking thing, and it's moving. And then the goal of this model is to drop this package here. Yeah. Yep. So you can do these type of simulations, right? And here what we are doing, this platform is again called SimScape Multibody. If you've not seen that, this is where we can have, like, if I go, this is a plant, right? So if I go inside the plant, you will see that we have all this chase, the quadcopters, and there we get all these blocks, right? These rigid transforms and stuff. These are basically as part of SimScape Multibody. If I go to this library browser, that's where, like, you might have, this is the base Simulink. Now, if I go down, there's this thing called SimScape, right? And this is where you can do these type of models where you can have the component level design of the whole model. And here you can see that, let me zoom in a little bit. So inside this library browser, inside multi-body, you'll see that there are a bunch of these things, right? So there are here, if I go inside, this DOFs, the joints and stuff are there. So we can create the model of this plant here. The plant here is the quadcopter, but you can have other things as well. So you can make things like, also if you have like things, SolidWorks model or AutoCAD model, you can import them as well here, right? That's the whole idea. Um, Okay, so this is a model where you have the whole thing together, multi-body, and then you have to identify where to drop the package, and we're doing this. If you want to dig deeper into this model, you can go here, just Google package delivery quadcopters MATLAB, and you will find this and you can run this. Yeah, right. So this is one, but here it is doing, there's an onboard camera, but we'll go into a little more deeper on the perception bit from now on. So where does perception comes in? If you have an onboard camera, if you have to find out where the image comes into the picture, and then how do we do this? So I'll come to that, and that's where all these things come in the form of machine learning or deep learning, right? So if I have to show you another interesting example, like if we see here, um, I show it some images, and it's this ice cream. We know all these things, but if you show all these things to an algorithm, ideally it should show that what it is, right? So it is, so let's say if it's showing into this French fries, it is showing French fries. That's where we can get started. Like a hot dog, it's showing hot dog. Pizza, it's showing pizza, but not always food. I mean, you can have a drone to fly and identify your food. So you can have a drone, it goes around, find out which restaurant has which food. Based on the image, you can go to that restaurant, right? Something like that. But then if you have to do something like this, anybody knows how to do something like this? If you have a camera and you have to identify objects, what shall we do to do this? You can put again in the chat window if you have any thoughts, what to do with this. Like if you have an idea of a camera that's giving you information and we want to find out what each object is. Anytime I'll try to, how do you do that? Any thoughts? Image processing, yep. Image labeler. Yeah, you're talking about all the tools that we have in terms of MATLAB, object detection using, yeah, I think everybody is correct. Image processing is one, but after that, we have to do something like detection. And that detection can be through YOLO, as Ishant is saying, or it can be through other means as well. There can be multiple different algorithms. So I'll show you one thing. So I'm just trying to get my phone. Now let me do one example live on this. So what I'm doing here, if you can see the MATLAB window. So what I'm doing here is I'll run this script and you will see what happens. So I'm kind of using the camera that I have with me. Which camera do I have? I have my mobile phone. Okay, so this mobile. So I'm trying to trigger the phone camera basically. Okay, and I have some simple code written here. Um, and then what it's doing is it's triggering my phone. So using my phone, I am taking an image live now. And then see, it has taken, this is the image I took and it is classifying it as a mouse. If I take an image of I have this coffee cup in front of me. So I'm taking that, this one, right? This one, it says lens cap, by the way. So anyway, if I take an image of the monitor through which your all chats are going, the room I am in, I'll take one of those. Um, so it's showing this and it's because of the rotated and stuff like that. Um, anyway, so what we are doing is we are taking some images and it is categorizing or identifying, detecting what object is this. Yeah, so I've stopped the code now. Basically, what we are doing here, this is the simple code here. What we are doing here, we are just taking this mobile device means I'm just connecting with my mobile. So you can connect with your phone or you can also use your webcams and things. I wanted to do phone because phone we can move around. Then what we are doing here is we are using the back camera of the phone. We are using this pre-trained network called AlexNet. Anybody knows what is an AlexNet? You can put again in the chat if you know what is AlexNet. So I'm using a pre-trained network called AlexNet, taking an image, resizing it, and then predicting it. Yeah, it's a very simple thing, so nothing much difficult. Using a network, and then after getting the network, um, and after that we sort of resizing and then predicting. Okay. Okay, guys. So one question from Kushin: where will you use image classification for processing? Where can we use these type of things? If you have an onboard camera on the drone, where can we use these type of uh, technique? What will help you? Like here, I'm taking images of cups and stuff. Specifically for Aerothon, where can we use image processing for classification? We can do using this AlexNet stuff. You can do using YOLO, what Ishant mentioned. So in this specific example, there is one case where I'm doing image processing and one case where we are doing object detection, right? Anybody wants to take up the question of where will you use image processing for processing? You can put in the chat if anybody has a response. While we continue, so here, this resizing thing, what we are doing, resizing is basically image processing, right? Because we are resizing the image to fit in this network called AlexNet. This is the network. This is a neural network. It's called convolution neural network, CNNs, if you are aware of the terminology. And here we are using this thing called pre-trained network AlexNet. So similar to this, you can use YOLO as well, right? Apart from AlexNet, there are a bunch of different other networks which you can use. The good thing is all these are sort of pre-trained. You can retrain it with your images. Like say, for example, if I have to do the package delivery, right? And if you have to find out that I have to deliver this package to specifically this location, or if you have to specifically find out somewhere where we have to, like some of the drones, we need to find out an agricultural application that the drone has to identify some specific plant and then it has to spray. Or it is doing a surveillance that it has to find out an image and it will trigger some alarm if some intruder is coming. So in all those cases, we can use these type of pre-trained neural networks. And then based on that, we can detect or classify an image. Does that make sense? And this type of things are used in bunch of different cases, right? You can see in many applications where it comes across, where this becomes useful. Anybody wants to take up Kushin's question? Where will you use this? Anybody wants to mention? Okay, image classification to identify people in disaster. Awesome. Yeah, that's a good area. So what we are doing here, just to kind of give you an idea, So this is part of something called machine learning, deep learning, right? Um, the difference between machine learning and deep learning, in deep learning we use something called neural network, right? Architecture of a neural network. In machine learning we don't do that. What is happening is inside the deep learning area, we give bunch of different images to some algorithm, and it can classify whether there is a car, truck, bicycle, people, as Ishant mentioned. So you can do many of these type of classification. That's the whole idea that you can do here, right? um, and that's the whole concept. And now what neural network to use, how do you train it, how do you do these type of things, is what comes as part of this whole ecosystem. Okay. And this is there in many cases, like, if you see here, this defect detection type of a stuff. Some of them are, this might not be UAV specific, but there is a lot of these applications that comes in perception. All these things are using images and then deep learning on top of that, right? Okay, so I think this one we already did, this deep learning in 6 lines. So this example that we did just now, this is basically, if you recall, this is essentially using 6 lines of code. If anybody wants to know more about this, or let us know. This is there in our sort of example as well, but it's very simple. It's just like this while loops and things are just basically we want to make it in a loop. But the bottom line of this is just getting this pre-trained network, resizing, and then predicting. What predict does, it gives you a numerical score. So basically this has multiple classes. This network is trained with some images, right? And it can identify only those type of images. So that's what it is doing here. So it predicts a score and then it finds out which has the maximum score. Okay. Is this making sense, this part of deep learning? Any questions on this? Okay, let's move on then. So not only AlexNet, right? You can have bunch of different type of models here. So AlexNet is one, but AlexNet is also very primitive actually. Now there are multiple lightweight. So if you are targeting any hardware where you want to deploy a deep learning algorithm, you might have to look for something which is lightweight and computationally efficient. So SqueezeNet, MobileNet, ShuffleNet, these can be good ones. Then object detection, for object detection, these are good. So these are for getting started, AlexNet, GoogleNet. But then after that, you can go for ResNet. Somebody mentioned about YOLO, that is also an option. SqueezeNet, these were also good options, right? You can see into any of this model which makes better sense for your application. How do you find this out also is if you go to MATLAB, there is this thing called apps, right? If I go inside apps, if you go to apps, right, there is something called a deep network um, designer. So if I go to deep network designer, right, this app, then if you click on this, yeah, so this page opens up. And inside this page, you can actually create any neural network. And before that, this starting page comes up where we can create our own network. Like typically for images, we use something called CNNs, convolution neural network. Or for signals, I think for UAVs, we don't specifically need signals, but for signals also, you can use some other type of a neural network. Now here, what is happening is you can see that we can get a neural network from PyTorch or TensorFlow. If you have a PyTorch based or a TensorFlow based network, we can bring them in as well. And apart from that, if I see this image network, there is SqueezeNet, GoogleNet, ResNet. So you have a bunch of different type of networks. AlexNet is the one that we used. And then there are other networks which you can use. So if I just open up any of this network, the network basically comes up here. And then you can modify this network. Like if say, for example, I think you mentioned about Ishant, you mentioned about identifying people. So this is a CNN neural network, right? Convolution neural network, but this is not trained with say people. If you want to retrain it with people, right? Because the architecture of the network is already there. So you can use it as it is, but you can retrain the network with other images, and then you can use it for other classification purposes. Okay. Um, that's the whole idea. Like you can use a already existing network so that you don't have to create this whole architecture, and then you retrain it with other images. You get some 100 images, train this algorithm with 100 images, change this final output layer to how many classes you want to do, and then by that we can use this, right? So this is, I mean, if you want to explore more, there are multiple deep learning examples and deep learning convolution neural network things which you can do with MATLAB, and use this graphical interfaces. Right here, you can see this thing. Right, if you see here, it contains multiple things. At the end of the day, if I go inside this this layer, right, this is called fully connected layer. You see here this weights is 1,000 times this, which basically means that this network is trained with 1,000 images. But if you want to more things, then we can try to retrain it. That's our idea. And as with any other apps in MATLAB, you can export this as a code. So you can, whatever you do in this app, you can export as a MATLAB code, and then that code can be utilized for a few other purposes. Right. So this is basically a graphical user interface where you can play around to create your neural network or use any existing neural networks and change it as needed. And that's where the deep learning concepts come into the picture on top of your images. Okay. Again, if you have any questions, feel free to put in the chat. Okay. Yeah, so some of the things that happens. Hmm. Right. So I think there's a question from Om. How can we integrate the already trained model with Simulink to test the Simulink custom model? So the thing is, you can also grade these networks in Simulink. So let me open up Simulink, and I'll show that once we open up Simulink. So inside Simulink, you can also, so this is Simulink, right? Um, so if I go into Simulink thing, right? So you can have your existing Simulink model. And then if I use something like image classifier, right? So this Simulink model, if you look into this Simulink model, this has an image and there is a prediction. If I go inside, you can see that you can use network from file, you can use Simulink, you can, I mean, squeeze a net. So you can put your neural network here and the prediction will come up outside. So you give it an image and then it will predict as well. So the same things that we did in the MATLAB code, we can use it in the Simulink model. You give it an input in my image and it can do the prediction out of it in terms of what it is, right? So basically you have this model called image classifier. If I search here neural network, you will see that we can get PyTorch models as well, TensorFlow models as well. So you can use these blocks inside your existing Simulink model for prediction purposes. And if you want to see more, there is I think there is one example which you can also do. Simulink deep learning image classification. I'm just Googling. I think this is there, or else I'll show you the model as well. Yeah, this one. So image classifier deep learning with Simulink, right? No, not this one. Yeah, this first one. Classify images in Simulink is in GoogleNet. The same thing what we are doing in AlexNet. This thing we are doing in Simulink, right? So we're giving an image and it's predicting. I'll put this link in the chat as well for you guys to go through. So it's doing the same thing. As you can see, this is that block, the image classifier. We give it an image and it's this, and you can integrate it within your existing Simulink model. Okay, so this is one part of things. Let's move on. And yeah, so basically, I think that's where all these things, I think we just went ahead of me. That's what we were talking about. Once we do the data, once we get the image and understand the data, we do this part, which is the deep learning models. I showed you a simple model of AlexNet or GoogleNet. You can create your own neural network or you can do all these things. And then the part becomes, how do you integrate with your existing system? That is this part. And that's what you exactly mentioned. you can integrate with your other part of the things, and I'll show you an example on that. And then we deploy it either on the embedded device or hardwares and things like that. These things we can skip what exactly the neural networks are. If you're taking an AI course on deep learning, you will hear more. Like there is this input layer, there are a bunch of this, hidden layers, and finally output layers comes. Basically, everything in deep learning is evolved around these neural networks, these layers and how they're connected, and that's how it moves, right? That's where it comes in. Okay. The other thing what we use is integration with things like Cuboid and Unreal Engine. So let me show you one example on that. That is also pretty. If you're doing something with Unreal Engine, that's a pretty interesting thing that we can do. So I'll again open up one more example. So I'm just opening up in my thing. Okay. Okay, so let's do one on this core simulation with Unreal Engine. So I'm just opening up one demos on Unreal Engine. So the good thing is when you are using Simulink, you can use many of these things which can help you to visualize. I think everybody might know what is Unreal Engine, right? So you basically do before deploying with the hardware, you actually see a visualization of what's happening through many of these animations. So we do these things in the animation front in Simulink. And then you actually get comfortable with what we are having. So there is this block called Simulink 3D simulation configuration. Here, this is all these blocks. The usual way you get blocks in Simulink, you can get this. So simulation of 3D sim configuration. If I search for it, you will see all this thing. Simulation 3D sim configuration, right? This block is there. So all in this blocks, you can select what type of scene we want. There is a US city block that I'm using here. This one is a simulation 3D of a UAV quadcopter, and we are giving in the translation and rotation of our quadcopter. And this is for visualization. We are just playing it. So if I run this, this is just a US city view where you can change the translation and rotation and see, how the thing is moving. But at the back end, we are using Unreal Engine visualizations to visualize this. Let's hope this runs, and then we'll be able to visualize this further. So you can change the translation and rotation here and see on what is happening. Right. So basically, this is the view. And you can see here that this is the view that is coming up. This drone is moving here, and we can see the US city view here. And we are basically in the view one of the views we are saturating. So here we are saturating the depth. So that's why we are getting this type of view. So from the onboard camera, you can take images, but the images you can also change real time and see what sort of views we are getting. So here we are changing the view as such, and kind of saturating it so that the camera image, so the real image is this, and this after the processing bit, the image is coming like this, where we are kind of making it grayscale and saturating the intensity. And these type of views can come inside from your Simulink environment as well. So what we are using, these are the blocks like simulation 3D camera, and this is the original one, and this is where we are sort of saturating and then getting the view. We just need to use this block and make it happen. You can change the translation. So we are using a ramp signal XYZ as translation, the XYZ velocity. And here we are giving a rotation. We have given essentially 0 rotation here. If you change it, you will see that the rotation will be given to the quadcopter. So this is basically something very simple of integrating with Unreal Engines as well, which you can do. Yeah. Yeah. So this is one. So integrating with Unreal as well. Then other things, what you can do is you can also integrating with things like ROS or Gazebo. So if you want to send out the information through, like this example, what we are doing is we are doing this quadcopter movement, but also seeing it in Gazebo. If you want to see it in a Gazebo platform, you can, there are a bunch of ways by which you can integrate with Gazebo. If you are using Gazebo, you can have a, if you are using Gazebo, you might know you need an Ubuntu machine, a Linux machine. So with MATLAB, also with the UAV toolbox and ROS toolbox, you get a virtual, um, uh, basically a virtual machine through VMware. You can connect to a virtual machine which has already installed these type of environments, right? Like this Gazebo environment. So this Gazebo environment becomes your one ROS node, and your MATLAB in your host computer becomes another ROS node, and you can communicate with each other, right? So this one also, if you want to explore more, you can see how you can integrate this virtual environments in Gazebo, and then have this ROS as a communication platform, and your MATLAB algorithm in your host computer basically communicates with each other. So this example is also there. Maybe I'll just show you where it is. So if you see Gazebo, MATLAB, uh, or say UAV, yeah, I think, yeah, can I control UAV in MATLAB and Gazebo? So there you have a bunch of different examples on that as well. But in general, this is what you need in terms of, say, VMware, MATLAB, Gazebo. You need to go through this type of an virtual machine setup, right? Once you do this virtual machine setup, then you will have this. I'll send this thing in the chat. So basically, then if you follow this process, you will have access to this virtual machine which has the Gazebo platforms which we are talking about. And then whatever algorithm we built, we basically control things in the thing. So that is sort of the idea here. So you can have this sensing perception as a node, but then the control bit, which you have heard in the other talks, and you integrate all of them through a RAW. So that sort of a thing is also possible. Right. Now let's see if you have to do the UAV obstacle avoidance, right? So this is one such example. So we are doing here this example on the UAV obstacle avoidance. It's we are covering through all these setups. So we are creating a scenario. So this is the UAV scenario. Then the platform, which is our base UAV thing. Then the sensor model we are doing. So we can do all these things together. Then the LiDAR model is there. So where we are generating the LiDAR point clouds. Eventually what comes up in this model is, this whole thing is there. And then once you simulate this part, so you can see the whole thing is there. And then this UAV, what is going, the obstacle is coming. It knows that there is an obstacle and it will fly past through it. Right? This type of algorithms if we have to build. This example is also there. So you can see UAV obstacle avoidance in Simulink, where basically usage of these sensors enable us to bypass this obstacle. So yeah, this is another case of things. This example, if you want to see, I'll put the link again in the chat. Right, this is the obstacle avoidance part of things. Great. So I think some of these things we have covered. I'll show you one more example and then we'll come to the labeling aspect of things in a bit. Okay, so there is one very nice example which you can also go through, and I'll show you a little bit on that. See. So there is this thing called survey urban environment using UAV, and this one gets you to multiple of these things step by step. What it does is it has an onboard camera. The camera will move around, and you take different images out of it first of all. And once you take different images out of it, we use deep learning on top of those images, and based on that, we actually do some analysis. Okay, in terms of a deep learning. So this example is a good one in terms of getting specified coverage. So we are saying where the UAV can move, and once the UAV moves, after that, basically, let's see if I run this. So we are getting the trajectory we are getting one, this the US city block, which is where we want the UAV to move. And once we have this, we'll basically have the UAV to kind of take off and do the thing. It might take some time. We'll see if it runs, or else I'll just run the whole thing. So yeah, this is the where the UAV is taking off, and this is we are delivering this waypoint. This is where the drone is moving, and once the drone has moved, it's basically that's how every time it's moving, it's getting some images. You can see this is going in this path. And once the drone is moving, it's actually taking images, and that images we are using for our neural network application. So you can do the whole end-to-end thing of having the drone move around first, getting the images, then using your CNNs or the neural networks, the YOLOs or AlexNet, to basically scan those images and do things on top of that. So this is how you can see here this drone is moving. And now it is basically landing. It will land here. So we are making this drone basically move. And yeah, now it has landed. And this waypoints we have defined is where we want it to move. And if I run this, we'll just maybe just run it for a. I think it has already happened, the running. So this is once it is there, and what I'll do is I'll just load the data instead of going through it one more time, because that will take a lot of time. You know. Yep. So okay. Anyway, once we are done with this whole thing, basically, so once we are done with getting the drone move, then what we do is this is where it becomes important, where we are mapping and classifying the environment using the camera. So this is where you can see how we are using the CNN network to do the classification task on top of this. Um, so if I open up the script, I mean, the thing is, yes, so this data is there. Once we get this data, we are also doing some pre-processing. These things you can do or you can skip as well, depending on the things. So basically, if the camera is taking images from different directions, we can make it orthogonal and make it all 90 degrees. So that is the step. And after this is, so basically, this is the actual image, and then we are also converting into grayscale. So here we want to find out what is the roof of all the images. So imagine a defense related, application where we want to find out which house specifically with the drone, some things like that. So here what we are doing is the image that it is coming up, it is identifying what is a roof, what is a human centric, what is a road. So these type of things. And exactly that's what we are doing using a pre-trained network, like what we did with AlexNet or YOLO or GoogleNet. That's exactly the same thing that we are doing. And we are classifying, if you see here, we are classifying roof and non-roof. Or somebody mentioned earlier that you want to classify whether there is a people or not a people. So these type of things we can do once we get the images from this camera on board, right? Um, so yeah, there is a bunch of different things which we can do on top of this. Another thing that we need to do when we are doing all these things is labeling, right? If you might not have images which are already labeled. So for that, what we do is we use something called an image labeler. I think somebody, if you made mentioned about image labeler, on that, what we do is we load the images like what we are doing. So if you get some 100 images, you load the images. And on that, what we are doing here, if you see, we are taking some of the images and then we create ROI label, which is our region of interest. So we say this is a vehicle or this is a roof. So whatever images we are getting from the top from the onboard camera, and then we can use this image labeler to do our labeling. So we do it for 5, 6 images. Like here, what we are saying, this is a vehicle. And then we can use some automated algorithm to do it for all the images. Okay, right? So that's the whole idea. So we are using an algorithm here, and then using the algorithm, it will do for that labeling for all the images. So this is something that you can definitely try out in terms of labeling. And so do it for the labeling for 5, 6 images, and then use some algorithm to automate it for all the images. So labeling is a big task. So you can do the labeling on this aspect as well. And once you are done with the labeling, you use your neural network, the deep learning neural network, to do the prediction purposes. And then you integrate it with your Simulink model, add the path planning part of things as well. So then it becomes something that you can use it for your full application. Right. So apart from that, the other things which I think you guys have seen or you might be interested in is when you are integrating with hardware. So once we have all this code, you can generate the C, C++ or CUDA code. So if you're using Raspberry Pi, you can integrate with Raspberry Pi. If you are using Jetson, so if you're using NVIDIA Jetson, typically you will use something called a CUDA code, right? So from the MATLAB algorithm, we generate the CUDA code and then deploy onto the hardware. So where all you can deploy, so CPUs for Intel's and ARM processors, GPUs, NVIDIA, and then FPGAs, Zinc and HDL platforms. So if you're using something like a Raspberry Pi or something as well, so basically you have to go to this MATLAB add-on, get hardware support package, and from here you will get the hardware support package for any hardware that you are using, either a Raspberry Pi or something like a Jetson Nano. So this needs to be installed before you actually do the integration with the hardware. Right. So here you can see we have Arduino, STM. Similarly, this is the Raspberry Pi or this is Parrot Mini drone. So we have to do this step before we are integrating. Yeah, so this, and then there are things which we can do for PX4 autopilot. So there is supported, these are the PixOx and stuff as well. So if you're using PX4, there's this page called PX4 hardware support package, right? This also you can use as needed. So this is an important aspect. If you want to, this might not be very specific for Aerothon, but if you want to see the whole thing at a system, we have kind of this course material. You can go through this page, tiny URL MATLAB modular. You will see inside that there is a course on, this part. So you have the 6DUF model, the quadcopter control, where you will see something like a PID control and stuff. Then the trajectory, package delivery, that one that I showed, sensor scenario generation and sensor modeling, where you have the camera perception and stuff as well. And using that, basically, we use for advanced control, which you can do as well, right? So if anybody is more interested, if you can just go through this as well at the later stage. Yep. And then for more resources, you can scan this. There are some more models and demos on whatever I've been talking about. This will also be there in this QR code. So feel free to, scan and go through it later on. Right. I think we can stop here as we are on the top, but we can answer any questions and any thoughts anybody has.
Thanks, Shovik, for the session. Suman, can we please stop the recording for Q&A?